Yeah, so we'd just like to say thank you for taking the time out of your day to be involved in this bio project for the University of Texas. We're all students in the Bio 313 class, which is an intro level bio class, and we're really excited to learn more about your career in biology. And just before we start, do we have your permission to post this interview on YouTube or Vimeo as unlisted just to be viewed by like students in our class?
Yeah, absolutely, yes.
Okay, great. And then if you would like to just go ahead and do like a super quick introduction of just who you are, where you work, and what field of biology you study.
Great. I'm Joseph Flaherty, and I'm a professor of biology at Coker University. We changed our status a little over a year ago from college to university. Coker began in about 1908, initially as a women's school, and went co-ed in the 1970s, and now serves a population of students, about 1,200 students. So we're a comprehensive university that embraces the liberal arts framework for education. And I grew up in Pennsylvania and North Carolina, and I went to North Carolina State University for undergraduate, and I stayed for a master's degree in genetics and plant pathology. And then I worked for a couple of years at the University of Florida, where I was a plant pathologist, and I studied diseases of tomato and pepper. And then I went back to the laboratory at Purdue University, where I did a PhD in plant pathology and fungal genetics. And I studied specifically fungi that cause diseases on important crop plants like wheat and corn and rice, and more specifically fungi that produce mycotoxins. And these are toxic compounds that contaminate our food supply and animal feed and have global concern. And specifically, my projects were involved in identifying genes in the biosynthetic pathway and also regulatory genes. So I did a little biochemistry and molecular biology in my degree program. Then I stayed at Purdue for a postdoctoral position for the United States Department of Agriculture, and I was a research plant pathologist for about a year and a half. And that gave me additional training. And about that time, I thought for sure I wanted to teach, even though I didn't have a lot of experience teaching. I wasn't really a TA, or, I had very limited teaching experience. But when you work in a laboratory, you engage graduate students, postdoctoral researchers, and everybody's new at some point. So everyone needs training. So I really embraced the role of someone that could onboard new personnel and get them up to speed. And I really enjoyed that. So I thought in my heart of hearts that I would enjoy a teaching position. So when I was searching for faculty positions, I really was lucky to have an opportunity to interview at Coker. And I didn't know much about the university at the time. It was a college, and I just knew it was small, and I might be able to have an impact as a faculty member there. And mainly I wanted to engage students on research projects at the undergraduate level, because that's really how I got my start as a student. I answered a job ad to work in a laboratory as a dishwasher, and a few months later they saw that I could show up on time and actually be trusted, and I started doing experiments. And then next thing you know, I was publishing papers, and I stayed on for a master's degree. This was at NC State. So I thought, wow, if I didn't have that opportunity to work in a lab, I probably wouldn't have become a scientist. And so I really want to try to give back to students in that way, and try to engage them early as possible on a research project. So my role at Coker has been to truly foster those opportunities even beyond the sciences. And so I probably went too long on that one, Anna.
No, that's awesome. Thank you so much for sharing all that. That's really cool. What kind of classes do you teach at Coker, and what would you say I guess you kind of went into this a little bit, but what would you say is your favorite and maybe something that you might not like so much about being a professor at Coker?
Sure. Well, what I didn't really expect coming to Coker, this was 15 years ago, was how much I would enjoy intro courses, teaching intro courses. So I teach intro courses every semester. I also teach upper level biology courses, specifically advanced genetics, advanced cell biology. I've taught biochemistry, but really my favorite class is teaching new students biology, students that maybe this might be their only science course in college, and trying to get them excited about the process of science and how science impacts their lives, whether they go on to become you know um, leaders in the business field, or they become artists. I think everyone deserves at least a chance to see how science can impact our own lives and society. So I really enjoy the introductory courses, which for us it's more of a cell biology courses. Our intro bio 110 is what we call it at Coker, and I probably enjoy teaching that the most. Now, as
Yeah.
far as what you know, I always tell students, hey, if you can become go down the road of being a faculty member, you should try to do it. The downsides are that, and reason why it's some usually not an option for a lot of students, or at least not an attractive option, is that in science you can make a lot more money in industry, and and you can do very well in the medical field, of course, to become a physician. So we have a lot of students that are attracted for good reasons. They're not just the compensation, but to think that you can give back and help people. But I think one of the challenges of being a faculty member is the idea that you have a bitter pill sometimes to give the students. And unfortunately, if a student's in your class and they don't see why the class is important, they don't see how this is going to help them become the next step in their career progression, it's real hard to wrap your mind around cellular respiration or genetics or things like that. And I can't blame them. I think back when I was a student, I remember struggling in intro chemistry courses because I couldn't really understand how this was connected to things that I was interested in. So it wasn't really until I took graduate, or even, well, I guess it was senior level biochemistry and then graduate courses in biochemistry, that I really appreciated chemistry. And I think Dan could probably speak to this. He probably, did well in his Chem 101 course, but now he probably understands why those topics are very important to what he does now. And it's hard to understand at the point in time when you're a first year student, especially. So I guess that's one of the bigger challenges, is trying to help students understand that it's not just an information dump as you might think science is. It's not just about memorizing facts, and especially now where information's at our fingertips. We can Google and find equations, we can find pathways, we can find arcane information, but the reality is, can you synthesize it? Can you put together disparate pieces of information to solve a problem? And that's a big challenge. So I think that that's got to be probably the biggest challenge I face in my job, is just dealing with some of those issues. And also, we're dealing with human beings. Everyone has, including the instructors, have lives outside of academia. You can't just assume a student is not dealing with external issues, and it's hard to navigate those issues or help a student navigate some of those challenges. So it's difficult when you're dealing with people, where if you're just solely in the laboratory and you're dealing with your experimental system, it's much more tractable than when you're trying to deal with human beings that are maybe suffering, or they have challenges that you may not even know about. And I think that's probably the most challenging aspect of my job, I guess.
Yeah, that makes a lot of sense. And then I think my last question before I pass it over to Dan or Brittany is just what kind of research have you done throughout your career? And also, if you could tell us more about your research program on gene discovery in filamentous fungi.
Great. Yeah, so research is one of my early loves, and I really value that concept that we can be a participant in knowledge generation. And that's why I try to get my students excited about research, because even if it sounds like a simple project, if really the definition, what makes research different than a like a laboratory procedure where you're following instructions or a protocol, is that you don't necessarily know what the outcome's going to be, and you're going to learn something new. You're going to fill in a gap in our understanding that hasn't been filled yet. So you're expanding the knowledge base, and that's the very attractive part of research, is that discovery. So I really tried, even though at Coker, my job is to teach students, and I have a research lab, I have a research program, but I don't have graduate students, I don't have postdocs or technicians. So all of the research is accomplished by my students, who happen to be full-time undergraduate students, right? And they're like you guys, some of them may be athletes, some of them may have jobs. So it's really challenging in that way to really make progress in that area. So it's certainly, the pace of research is a lot different when you're in a position like I have now, compared to when I was at North Carolina State or Purdue, where I was working in a lab 50, 60 hours a week and just focused on research. And we took classes, but you fit that in around your research schedule. And so it's a different animal. So I think that if you were to become a faculty member at like University of Texas, you may teach a class now and again, but your main focus would be that discovery piece. So you might have a lab where you have multiple people working, graduate students that you're mentoring, and they're all focused on the discovery piece. So I think that I still integrate a lot of the projects that I brought with me from Purdue to get my students started, get my lab started, and those still persist because of relationships I have. So I have collaborators at Purdue, Southern Illinois University, North Carolina State, University of Arkansas, and they all host my students in summer for internships. Many have gone on to graduate school in those programs. So it's nice to have those. So I wouldn't really have a research program without those relationships and those collaborations. So that's where I think at a teaching focused university, you can have a research program, but you really need those collaborations with what are called research intensive universities, which University of Texas certainly is in that category. So I would have those types of relationships to bolster the ability for my students to have really high quality experiences, especially in the summertime. And I engage students here in the summer as well, and I get grants that can help provide support for those students, so I can pay them and go to conferences and things like that. So that's very helpful. Now, my research focus has also shifted because I have an interest in student success, and the National Science Foundation, which funded my first research grant at Coker and really helped me get my career going here at Coker. It was very much focused on gene discovery in fungi, but my last two NSF grants are focused on supporting specifically low-income students in biology to help them persist in the major and help them overcome these obstacles and barriers that many of our students face. So I've been very happy to be a part of that. It's a little bit more social science because, again, I'm dealing with a lot of issues related to human nature and things that related to metacognition, how student perceives themselves as a sense of belonging. Do they see themselves as a future scientist? Studies have shown that has a huge impact on a student's ability to stick with a STEM degree. So anyhow, I've been very fortunate to be a part of those projects and lead those projects. And I'm also leading an initiative that's funded by the Howard Hughes Medical Institute for inclusive excellence. They have an inclusive excellence program. It's in its third iteration. And Coker is now part of what's called a learning community. So we're progressing towards trying to implement meaningful changes to embrace principles of equity, inclusiveness on campus, from hiring faculty, promotion, the students, and how teaching is evaluated. There's a lot of hidden issues structurally. You hear of like structural racism, structural issues, gender inequality, and a lot of these projects are focused on trying to ameliorate some of these institutional problems that persist in all of our institutions. So I've been very grateful to be a part of those types of projects. So it's a little different of a research focus, but I still have a firm footing in the fungal genetics aspect. I have students working with me right now, and I have a project, a collaborative project funded by NSF with my colleague at Purdue University, and that helps fund students at Coker to study the process of RNA editing in filamentous fungi. So it's been fun, and that's one of the upsides of working in academia, is that you can drive what you work on. You don't have a company or someone on top saying, hey, we want you to work on this. Generally, your universities hired you because they know that you bring expertise to the university, but they really leave it to you to cultivate what kind of projects you're working on. And as long as it's in the best interest of the students and the university, you get supported to do that. So I'm very fortunate that I'm very grateful that to have a position like this where I get to kind of decide what I work on.
Yeah, that's really interesting. Thank you for sharing all of that. I think Dan has some questions now.
Brittany, did you want to take the next set?
Okay, yeah, I can. So what or who got you interested in the biology field?
That's a great question, Brittany. Well, my interest in science started very young, like probably all of you guys, through watching programming. Like I remember watching the usual David Attenborough nature series on PBS, and probably more profoundly, I watched the early episodes of Cosmos. At the time was narrated by Carl Sagan, and he became probably one of my early heroes. He was an astronomer and popularizer of science, and the modern day equivalent is Neil deGrasse Tyson, which you may know who Neil deGrasse Tyson is. And I listen to his podcast now, and he even is the narrator of the more modern version of Cosmos you might have seen on TV. But so I got interested when I was very young in science, and like a lot of people, I was interested in all different types of science. I like sharks and astronomy, and I loved everything about science. So I knew early on, even though my parents didn't go to college, I didn't have any scientists in the family, and I didn't have that type of guidance. So, but for some reason, I just gravitated towards science. And as an undergraduate, I majored in zoology, which is the biology of animals, and I had a minor in genetics and biotechnology. So I knew I was gravitating, while I was taking those courses as an undergraduate, I was gravitating towards biotechnology. So I really liked the idea of using tools to solve problems. So I really was attracted to the idea that you can manipulate genes and you can do techniques to study genes at the molecular level. And I just thought that was completely fascinating. And then the biggest impact I had, which I referred to earlier, was I got hired in a lab. And at that time, and it may be like this now, it was hard to get an internship or a job in a laboratory. It's not quite the case at a place like Coker, if you have a student at Coker that just says, hey, I'm interested, we can make that happen. But when you go to a large university, where at NC State certainly wasn't quite as large as UT, but there was probably hundreds of people that applied for that dishwasher job, right? And so for some reason I got the job, right? So I don't really know why, because there's a lot of great students there, you know, and I didn't stand out. I was just a student, right? And so I worked hard, and I showed the people that the PI, the person who ran the lab, appreciated that I was interested and I could work hard. And I think that's a big part of it. You gotta put your best foot forward for these opportunities. And I really gravitate, even though they were working in plant pathology, working on fungi, things I didn't take a single botany class because I thought I hated plants. And the reality is I ended up, you know, kind of studying plants because they are the hosts for these pathogens that I'm interested in studying at the graduate level. So the reality is I have a completely different perspective, but it was all because I had that experience. So I think my best piece of advice for students is to try to get some type of experience, bug people until you get some type of experience, because even if it's an experience that's not positive in that way, I think it's helpful, because it's good to know what you don't like. So if you don't experience anything, you're not really sure what you like or don't like, what you may be passionate about. And to be honest with you, put the time in to completing like a STEM degree, and I know Dan can speak to this because he's almost finished with his degree. It takes an enormous amount of work, right? To get to the point that you guys are moving towards, it's an enormous amount of work. So you have to be passionate. You have to really enjoy what you're doing, or else it just becomes almost impossible tasks. So I think that would be my best piece of advice, is to try to find something that you really, really enjoy. So like, you know, I know Anna well enough to know some things she really enjoys, and she puts an incredible amount of effort, and that leverages her talent, and it ends up being a good recipe, right? So that I think that happens with your, with everything in life, right? So, and I want what's best for the students. I want you to be as happy with your job when you're my age as I am, right? And to get to that point, though, it really helps to try out some things you didn't like. When I worked in Florida after my master's degree, I didn't know what I really wanted to do. And I really learned a valuable lesson, because I realized that that type of research I was doing, even though I was successful, I have a couple publications from that experience, but the reality is I knew I didn't want to do that for the rest of my life. And that was a very valuable experience. So those types of experiences can help set you on a direction that ultimately you're happy with.
For sure. Thank you for sharing. And then also, how has your experience influenced the way you teach, since biology is a rigorous subject?
That's a great question. For whatever reason, the teaching part fell into place for me. So I didn't have a lot of training, but I'm always looking to get better. So I always seek out opportunities to become a better teacher. I embrace technology. I'm always looking for tips, or, you know, I sit through webinars and try to become a better teacher. And I think the strategy that's worked for me is to always approach it like you would approach it as a scientist. When you're a scientist, you're constantly conducting experiments, you're refining, you're making mistakes, and you're always willing to change something to optimize a system, or to try to design an experiment that's going to test your hypothesis in the best way possible. So as a teacher, I apply those same principles, where if you sat in on my classes over the years, you'd say, wow, how he's teaching Bio 110 is different than it was last year, and it is really different than 5 years ago. I think being willing to change is really important for a teacher. And sometimes I'll try things out and I realize it's not working, but I'm not bought into it enough where I'm like, well, if I did this last year, I better do it this year. No, I always try out new things. And I think students have come, I think they benefit from that because one, I always keep track of data. So I always look at my student success rates. I look at, how many students are failing my class, right? And I always try to improve on that. And I'll have semesters where I feel like, everybody in the class is capable of making an A. And I start from that premise. The reality is it never happens. But the reality is I try to set up the atmosphere as like, look, you guys have the capacity to succeed. You have the capacity to make an A. And that's what students generally want. They want to take a class. They want to try to make an A or the best grade possible. And the reality is I think that helps set the kind of their mindset and give them more of a growth mindset, because I have a growth mindset. I tell them right away, look, I'm always trying to improve. I'm going to try out some things this semester that I haven't tried out before, but I'm going to promise you that I'm going to be mindful to make adjustments as necessary. And I guess that's kind of how I approach my teaching. I'm always willing to make adjustments and try to become better. I think that's the concept of Toyota's, that Kaizen principle is we can do better next year, right? We can do better tomorrow. And I think that's a wonderful principle. If you just say, whatever I'm doing well now, I should be able to improve in some way. And that's kind of how I try to view teaching. I think it can always be improved.
Thank you for sharing. That's all the questions I have. Dan?
All right, so obviously the last year hasn't been as ideal for everyone as we all expected. How, if at all, has the pandemic affected your research and any teaching opportunities you have with Coker University?
That's a great question, Dan. That's the that's the big question facing higher education. How have you been able to adjust to the pandemic? And people are doing it in different ways. Coker last year, like most universities, we went abruptly, I think around the end of March, we went to online learning. So we went from in-person to completely online without a lot of lead time. And that was a challenge. And the way I handled that was I tried to see it from the student's perspective. So I didn't have any synchronous class meetings. What that means is students show up at your normal class time and they got to be on Zoom and they got to stay with you that whole time. So I turned everything asynchronous so that way they can pretty much handle the class on their schedule. And I think that worked really well. I did lose a few students who just didn't have the tool set available to really handle that much, I guess, freedom for their schedule. Some students really benefit from having like a regimented schedule. So I could see how some students were negatively impacted by having, wow, it's on me now to watch the video or to do the online assignments. And fortunately, I had enough integration with our learning management system. We use Blackboard that I had a lot of integrated like online discussions and online components that it wasn't too difficult for me to switch to fully online. Although I never taught a fully online class before, so I'm sure that was imperfect. And then this year, starting in the fall, we were hybrid. So that means to try to reduce density in our classrooms, we're asked to move about half the class, give or take, online, so you can have less frequent course meetings, so you can have low density classes for social distancing. I thought that really worked well, and it's still working well. We're still in that environment right now. And I think I've learned a lot because it kind of forced me to do some things with technology that I probably would have been a little slower to embrace or even try out because of, when you see students in person, it gets you out from under leveraging a lot of the technological tools that are available. So I think when we crawl out of the pandemic, which I'm hoping happens sooner than later. Maybe this fall will be kind of normal, hopefully. I'll still have some things that I did that's hybrid. I'll integrate that into my courses in the fall, because I think students are much more able, because they have experience using online technology, but also it kind of helps the learning experience. I found students are actually doing better in some ways. They're mastering material a little bit better, because the downside to what's called like a didactic delivery of course information, that's where your teacher kind of speaks in a lecture hall and kind of just gives the information out and you're furiously taking notes. That's really not the best way to learn, okay? So I think that's pretty well established. So I think integrating more active learning strategies where you have students participate online and still have an in-person component, there might be something that's optimal in that recipe. So I think the world has changed, just like in other aspects of business, where people now are probably not going to go back to the pre-pandemic, their day-to-day may be much different, like remote workers. I think there's going to be a lot of people having more flexibility with their jobs, because they know that, hey, I can do a lot of this anywhere, right? I don't have to be in my little cubicle in my office. And I think higher education is going to be very similar. I think it's going to be for the better for students. I think we're going to have better learning outcomes when we leverage kind of things we were forced to do in the pandemic, to now saying, but it's going to be up to us as instructors to make sure we don't just abandon some of those innovations, and just for the fact that now I can go back to my old lecture style because we're all back to normal. I hope that doesn't happen. So that's kind of what I'm looking forward to, is I think we can actually make improvements. I'm always looking for the positives, and there's not many positives from the pandemic, but this could be this whole paradigm shift of how, and you saw it with online learning. I think UT has a large number of online students. It's a phenomena across the country, and I think it could be done well. It could be done poorly, but I think it can be done well. And I think we have to figure it out, what the best model for to maximize learning. And I think it's going to be somewhere in that hybrid realm, where we still have some face-to-face, especially with experiential learning, people doing research in laboratories, things like that. That can't be pushed online. But I think some things can be put into the technological realm, and not have this organic chemistry lectures of 200 students, and the person, I had like a 90-year-old organic chemistry professor. He probably won the Nobel Prize, but he was there, writing with the chalkboard. And I think those days are probably gone, and they should be, because I don't think that's as effective a way to learn. It's more of active learning, group work, things what you're doing, your class assignment's a good example of active learning. It's, you're learning leadership skills, you're learning all these things that you really can't learn if you just show up in a lecture hall and someone's barking out information, So I think that that's going to be the positive outcome of the pandemic, I think, on higher education.
Right. No, definitely. And just the last thing I kind of want to touch on, of course, I mentioned before, I'm a fourth year, applying every chance I get for any job opportunity. And for yourself as an educator, how do you view the current job market and the current opportunities that are given within the biology field? And if you had any advice to give to a graduate just coming out that wants to look into furthering their biology career, what would that be?
That's a great question. And it's the job market, I think, is looking really good especially for students with the science trajectory, right? I think, and there's other aspects of other sectors of the economy that are doing better than others. But I think we're at the point where we hire a lot of people on H-1B visas these are international workers. So like if you're a company like Google that has like 50,000 employees globally, we hire a lot of scientists that are non-U.S. citizens, and certainly that is a strength, right? One of the best things about graduate school for me was getting my interactions. I have lifelong friendships from for people that are from all over the world, and that's because of graduate school. So I think there's certainly that strength, but it becomes an aspect of national need. We need scientists. We need future scientists to fill these positions. So I think what we're really running a deficit. So the reality is, moving into the job market shouldn't be too much of a problem, but finding what you're really passionate to work on, finding a company that you would be happy to work for and feel like you can have upward mobility and get training and be treated fairly. I think those are all key components, and also balancing it out with your family and other considerations. In academia, you pretty much go where the job is. I applied for faculty positions in Hawaii, Iowa State. I was going to go where I could get a job. But my wife has a PhD. We have to balance out those considerations as well. So everyone's different for what their considerations are. They have to balance and try to figure out. But science, I think, is looks very good from the job market goes. I think that we're always going to need scientists, qualified people like Dan and Brittany and Anna that become our future leaders and keep that discovery moving forward, because I don't see it contracting at all. I really think we need more people. We need more engineers. We need more scientists. We need more teachers to excite the next generation of scientists, get them in thinking about becoming scientists. Because we do lose a lot of good people to other disciplines because they feel like, well, I want to play it safe. I'm going to become an accountant, or I'm going to do this. And they may have a good mind and enthusiasm for science, but they may feel like, hey, it's a kind of an ambiguous future. There's a lot of things you can do, and you may not even be aware of all the possibilities. Dan you're obviously applying for jobs and stuff, but I think we need more people like you that have that training to fill the needs. And then you've got to decide, am I going to work for private industry? Am I going to work for the government? Am I going to work for university? So you have those choices, and I had to cross those bridges as well. People like me can get jobs in industry, agricultural industries like Syngenta or Dow AgroSciences, or I could work for the federal government like USDA, EPA, NSF, NIH. And that applies to you guys. You're going to have those options, and you just kind of balance them and see what's in your heart of hearts, what ultimately would make you happy. But to be honest with you, people, just like students will transfer to other institutions, you're going to move. You may move around. You may work for a company for a couple of years, and you just want to leave put your best foot forward, because it's all part of a progression. So it may not be the place that you spend your career at. It may be somewhere where you look at it like a postdoc, where you may be there for 2 to 5 years, and it just gives you some training, and then you move on to the next position.
Awesome. Well, thank you again for meeting with us and allowing us to interview you. It's been very constructive, especially for the course. We really appreciate you answering our questions and giving us a lot of insight into your work as a professor and your work with your research. So
yeah, thank you so much.
Really great talking with you.
That was great.
I really appreciate it. You guys are the future. So I can't, I wish I could talk to students more often in this way, because the reality is we need you guys to carry the torch. Brittany, I know you could be a business, but we need leaders. We need people that go into these in the business sector, in science, in the legal sector. You know, you think about the opportunities in law school and business, and it's just, you know, there's a lot of almost limitless opportunities, and we just need your very bright minds to move forward. And I'm glad you guys are in this class and pursuing your degrees.
Yeah.
Thank you.
Thanks again. Yeah, I definitely learned a lot. So this was really good.
Thank you so much. Well, I appreciate your time, and good luck. And I hope you have a good rest of the semester and a great summer.
Thanks. You too.
Thanks.
Thank you. You too.
Bye-bye.